Because it means stars cannot shine forever, including the star at the centre of our solar system. At the end of its life, the sun won't simply fade away to nothing. As it begins to run out of fuel, its core will collapse, and the extra heat this generates will cause its outer layers to expand. In around 1 billion years' time, this will have a catastrophic effect on our fragile world. Gradually, the Earth will become hotter and hotter, so there will be one last perfect day on Earth, but eventually the existence of all life on this planet will become impossible. Long after life has disappeared, the sun will have grown so much it will fill the entire horizon. It will have become a red giant, the last phase of its life. Our planet might not survive to this point, but if it does, little more than a scorched and barren rock will remain to witness the final death throes of our star. In 6 billion years, our sun will explode, throwing vast amounts of gas and dust out into space to form a gigantic nebula. And at its heart will be a faintly glowing ember, all that remains of our once magnificent sun. It will be smaller than the size of the Earth, less than 1/1,000,000th of its current volume and a fraction of its brightness. Our sun will have become a white dwarf. With no fuel left to burn, a white dwarf's faint glow comes from the last residual heat from its extinguished furnace. The sun is now dead. Its remains slowly cooling in the freezing temperatures of deep space. Looking at it from where the Earth is now, it would only generate the same amount of light as the full moon on a clear night. The fate of the sun is the same as for all stars. One day they must all eventually die and the cosmos will be plunged into eternal night. And this is the most profound consequence of the arrow of time, because this structured universe that we inhabit and all its wonders, the stars and the planets and the galaxies, cannot last forever. The cosmos will eventually fade and die. First will come the end of the stelliferous era, the end of the age of starlight. The largest stars are the first to disappear, violently collapsing into black holes just a few million years after their formation. But long after they're gone, just one type of star will remain. This is a picture of the nearest star to our solar system, Proxima Centauri. Now it's only 4.2 light years away, but the reason it doesn't stand out against the much more distant stars in this photograph is that Proxima Centauri is incredibly tiny. It's a kind of star known as a red dwarf star, and it's only about 11 to 12% the mass of our sun. But to our eyes, it would appear to shine 18,000 times less brightly. But red dwarfs do have one advantage over their much more luminous and magnificent stellar brethren, and that's because they're so small. They burn their nuclear fuel incredibly slowly, so they have lifespans of trillions of years. And that means that stars like Proxima Centauri will be the last living stars in the universe. If we survive into the far future of the universe, then it's possible to imagine our distant descendants building their civilization around red dwarfs to capture the energy from those last fading embers of stars, just as our ancestors crowded around campfires for warmth on cold winter's nights. The reason why Proxima Centauri burns so slowly is because its small size and low gravity mean its core is under much lower pressure than larger stars. This also means that its interior is constantly churning, whipping up the surface into a fiery turmoil. Explosive solar flares occur almost continually, even though it burns so dimly. But Proxima Centauri will eventually die. And like our Sun, it too will become a white dwarf. As the age of starlight ends, all but the dimmest flicker of light in the universe will go out. The faint glow of white dwarfs will provide the only illumination in a dark and empty void littered with dead stars and black holes.